Hello, everyone. Can everyone hear me okay? Yeah. Let's see. Yeah, so if you couldn't tell, I work for AWS, FSX for Lustre. The main gist of this talk is pretty much everything that we've done open source, plan to do open source, and everything in between. I have it split into a few different sections here. Just kind of a broad overview, some of our networking stuff, experiments with like LLVM, static analysis, things of that sort, the in-memory OSD, so storage backend, and then some of the results from the upstreaming effort and going to LSF last week with James. So first thing I'll go into is just general trends over time, AWS's contributions. So generated this nice graph with that Git incantation and a little bit of Excel magic. Not too much magic, but you can kind of see the general trend is over time, our contributions are increasing. There's some spikes and troughs, usually around large patch series landing, especially that one not too long ago was a bunch of tree-wide cleanups. But yeah, I expect this to go a lot more up over time as we onboard more contributors and get more of our stuff upstream. You can actually see the most recent downturn is mostly just busyness with LSF and LUG coming up. So talk about some of that stuff more later on. So yeah, EFA. So for those not familiar with AWS networking, we actually have two different types of network interfaces available. So there's ENA, which is kind of like a Ethernet, TCP/IP kind of stack. And then there's EFA, Elastic Fabric Adapter, launched in 2018, I think. That is closer, more analogous to InfiniBand on-prem. So basically an HPC interconnect, supports RDMA, direct storage, things of that sort. So around reInvent, we actually launched support for EFA Lustre file systems as a separate deployment type. So I guess the natural question is, why would we actually do any of that? Comes down to higher single node throughput. Basically, if you want to saturate a single node with Lustre file system on AWS, it's a lot more efficient to use EFA. So the kind of prime use case that we envision is the H100 GPU instances, the P548X large. They have a very large number of EFA interfaces, 32 of them, actually. And we've observed around 8 to 12x throughput improvements using EFA and Lustre. So in terms of hard numbers, that comes out to 800 gigabit to 1200 gigabit, which is 100 to 150 gigabyte aggregate throughput on a single node. The difference between the 800 and the 1200 is basically the difference between using just RDMA, so going to CPU memory, and GDS, where you're just going directly into GPU memory. Yeah, so in a lot of ways, if you know something about the design of Lustre networking and the Lustre networking stack, this is bringing Lustre into its natural habitat. Everything is very much RDMA oriented in Lustre, so very perfect pairing in a way. Yeah. So another advantage, one that I didn't explicitly call out in the slides, is there's a lot less resource utilization compared to doing a full like Ethernet, TCP, IP stack. So you can hit these very high throughput numbers without just spending 100% of your CPU cycles just pushing I/O. I think the 800 number, we got around like 10, 15% CPU, so very low utilization while still pushing a pretty high throughput. So yeah, if you know how InfiniBand works in the InfiniBand LND, the way that the hardware addresses are negotiated is using IP over IP. So each InfiniBand interface is assigned an IP, and you use that to basically get the actual hardware address so that the nodes can actually talk to each other. In an AWS environment, we don't have IP over IB. The IPs are assigned to each interface independently of that. So the workaround we have is actually an LNet layer change that does the same kind of negotiation, but using something similar to LNet discovery. So every node, right, if you have a P5, for example, you have 32 EFA LNet interfaces, and you'll have one at TCP LNet interface. And that LNet interface at TCP is responsible for negotiating, basically resolving the EFA address to an actual hardware address. If you actually want to look at the implementation of that, you can look at that LU 18808 to see what the LNet changes look like. Actually put out how the EFA interface addresses are derived. So if you look at that one at TCP interface, that would be the one interface you have on your P5. You take the host address part of that, you move it to the front, and then you take your PCIe bus number there, convert it from hex to decimal, and stick that at the end, and that's your EFA address. So just because of the peculiarities of AWS networking, you can guarantee that these are going to be within a subnet globally unique. So you can use that to know, based off an arbitrary EFA interface that you're reaching out to, where to ping to get your GID information, the hardware address. So yeah, what this means in practice is we're using it in a heterogeneous network. So you're always having EFA and you're always having TCP side by side. If you remember some previous work, I think HPE did UDSP. We're actually leveraging that same thing. So user-defined selection policy is prioritizing traffic between interfaces of different network types. So in this case, when you connect to an EFA-backed file system, you set a UDSP rule to prioritize the EFA interface for traffic. And also using LNet multi-rail, kind of implied since we have so many interfaces per node. Yeah. The only other interesting thing I think that's perhaps unique about our setup is the MDSs actually are TCP only, and the OSSs are EFA and TCP. So there's an explicit prioritization of speeding your bulk read-write traffic. Yeah. So that's kind of the high-level overview. So future work, upstreaming. There's no timeline right now. I would say next LTS, very likely. So if you follow some of the other tickets, this 18808, and follow the links, eventually you'll see the actual implementation. So stay tuned for that. The second bit is, if you recall James' talk earlier, he mentioned that GPU direct storage can't actually work with a upstream Linux client. The main reason is just due to NVIDIA having out-of-tree drivers, right? So they have the out-of-tree DRM driver and then the out-of-tree GDS driver. Typically a big no-no for an in-tree driver to interface with an out-of-tree driver. But very recently I learned that there's actually the peer-to-peer DMA APIs, the out-of-tree NVIDIA drivers actually interfacing with those. So there is a path, in theory, for GDS to be supported on a native Linux client. Something I haven't looked into super deeply, something I'm aware of, look into in the future, but stay tuned for that. I haven't made a ticket for it, or else I would have an LU in there. Yeah, so the next thing, kind of a phase shift here, is LLVM and static analysis. So LLVM, for people that are not aware, is the other major open source compiler toolchain. So you have GCC, traditionally used by Linux distributions, and then LLVM and Clang, Clang being the C and C++ compiler. One of the first projects I actually worked on, I think maybe 2 years ago, something like that, was implementing the build support for Lustre to build on Clang. That mostly involved getting rid of hard-coded GCC references, a lot of auto tools, kind of reconfiguring, and fixing a lot of different LLVM compiler errors. Started all the way at, I think, LVM 13 up to LVM 19 at this point. So you see quite a few patches in that kind of area. I think there's a lot of strengths to LLVM compared to GCC, especially for kernel development primarily. You won't find very many Linux distros actually shipping LLVM by default as their system compiler. But yeah, there's a huge set of default warnings that are a lot more helpful for development that LLVM includes and enables that GCC does not. And beyond that, LLVM has a much stronger plugin ecosystem that GCC does not have. GCC is kind of shied away from plugins historically, right? Because they don't want to necessarily expose the abstract syntax tree and then have third parties make proprietary plugins based off of that. But LLVM and Clang has a lot more open plugin ecosystem. So a lot of patches, the 8191 and the 18753, basically just running those plugins on Lustre, seeing what gets spit out, and then fixing everything. The first one is kind of a more trivial plugin, the find static one. It's pretty much just a single compilation unit. You find every function that's just not called outside, figure out which ones are supposed to be static and make them static, essentially. The second one's a little bit more complex. This is across compilation units. So you compile every single C source file, and then you aggregate the results together in a big hash table, and you can figure out where the dead code is. So that one's a more recent development. I think I have something like 1,000, 1,500 lines of code that were just eliminated because they weren't called anywhere. I think the oldest bit of code was maybe like 15 years old. Function that just got orphaned very long ago. I have a patched version of this same plugin, the X unused, that finds unused code in headers as well. Eventually I'm going to do macros to try to just sanitize a lot of the Lustre headers over time. So yeah, it's a very powerful ecosystem. I think my general recommendation is if you are doing any kind of Lustre development, you should strongly consider running LLVM in your CI, maybe have a developer look into it. It'll be very helpful, in my opinion. The setup is pretty straightforward. You have an LLVM kernel, and you basically just pass in the same variables to Lustre. There is a compiler flag, or configure flag. A lot of times I'll fall behind a little bit on some of the LLVM warnings, so you might find a few and you can just disable them. So if you have something that LLVM doesn't like, you can just shut it off. So yeah, everything should, in theory, just work if you do that. If it doesn't, feel free to ping me. I have my email at the end of this. I use this for development all the time, every single day. Yeah, so another thing, Coverity scan. That you might see patches flowing through there, or if you're a developer, you might get pinged about Coverity issues. For those not familiar, it's basically just another static analysis tool. The Coverity scan is basically the version that is offered for free to open source projects. I think also around 2-ish years ago, maybe a little bit less than that, I set up the project for Lustre, and I occasionally submit builds to that. I have fixed some of the bugs in the past. Honestly, I think more people besides me have fixed them. I think Arshad from Aeon fixed quite a few, Sebastian from DDN. I think Andreas looked at a few, and Oleg has been pinging people about it. So there's a few other people out there getting some use out of this. It's a useful tool, in my opinion, but the trickiest part is high false positives, a lot to sift through, and it is kind of a pain to iterate. So if you have a potential fix, you only have a very small number of builds you can do each week. So you can't really just easily see if, like, hey, does my patch actually fix this bug? So most of my work has been focused around just LVM and then playing around with the plugin ecosystem more than really diving into Coverity. I think for anyone looking at doing more static analysis for Lustre, probably, in my opinion, should lean kind of a similar way. I think you'll have a much easier time. Yeah, so future work is pretty much just like keeping up with LVM, just getting more up-to-date versions. I think 19 is the latest version, maybe 20 is coming around. And then there's some quality of life stuff that the Linux kernel has that Lustre doesn't have in terms of plugin integration. Pretty much for generating the compilation database that you need to run plugins. Linux kernel does that very automatically. For Lustre, you need a third-party tool, Bear, B-E-A-R. So might look into that. And the other thing is, this is more hypothetical, looking at a custom Lustre plugin, just to enforce things that might be useful to us. That has existed in the past to do some cleanups. I tried to revive those. I couldn't really get them working. And I think the things that they were checking for might be more deprecated in Lustre these days. Yeah, so another set of work is around the OSD. So for people not familiar with the architecture of Lustre, on the server, you kind of have your request processing, your target layer, and then the OSD, which is the backend, right? And then below the backend, you have the specific file system and storage implementation that you're using. So the two that are in tree right now are LDiskFS, right, which is just ext4, right, and then ZFS, which is ZFS, of course. So the OSD is the shim driver that basically makes Lustre speak the language of that underlying storage volume. So something that I've worked on, 17.9.95, is implementing an OSD just purely in memory. So basically allocate pages when you want to store something, and then if you reboot your node, it's all gone. That's something I have. Surprisingly small amount of code is needed to actually implement something like that. It's only 3,000 to 5,000 lines of code, depending on how you count it. The primary use case for this is testing oriented, at least in my view. It's not the only thing that it could be used for, but it's the main reason I put it together. I think about the client experience of setting up a test node. Almost every kernel, every platform has some level of client support for Lustre, or you can get something working with very minimal effort. The server side tends to be a bit more complicated because you either need a valid ext4 patch series or you need a valid version of ZFS. Not impossible, but a little bit more tricky. So in my view, the in-memory OSD is basically getting the server to that same level of platform support, just being able to run it on just anything. Pick any odd kernel, any odd platform, and have something that's reasonably well running. There's a few other things that have landed before the actual OSD. The OSD itself is still in flight, but there's some code deduplication. There's a lot of code shared between these OSDs. And just like kind of general improvements, I have those 2 tickets there that track both of those. A lot more that I have mentioned in a later slide. There's actually a kind of recent development, 18.8.13. Yingjin from DDN actually has another prototype. So that, if you're familiar with metadata write-back cache, it has an embedded file system, memfs, right? It's kind of like similar to tempfs or similar. So his prototype is basically taking that, and then from my in-memory OSD, taking the index code, the mount code, some of the infrastructure, and a few other bits, gluing them together, and then having that as a write-back cache fs OSD. That's another competing implementation. I've been spending some time reviewing that, testing it on my side, and he's been iterating it over the past couple weeks. The final version of this in-memory OSD concept will likely be some kind of combination of those 2 approaches. Yeah. So general timeline is probably around 217. Trying to get something that's just like functional, passes most of sanity, just landed, so I can use it to unblock other development-related tasks. I find it is a really huge help to have it when just doing any odds and ends kind of Lustre development stuff. So really just hoping to get it landed relatively near term. There's a few other things I have planned out, making it more debuggable. There's a lot of opportunity to do more like debugging and introspection in an in-memory OSD because you just have the entire end-to-end storage stack inside of Lustre. More deduplication. There's still some code that's just directly copied from the other OSDs, especially some stuff from LDiskFS that could be deduplicated. One day, I will write more documentation. Probably not any day soon, but it's on my to-do list. And the other thing is mirroring or write back. It shouldn't be too difficult, I say this without having looked into it deeply, to basically take a snapshot of the in-memory file system, just write it to an actual file system, just periodically. And then mirroring is basically doing the same thing, but instead of landing it to a file system, you just bounce it over to another node that just holds onto it. They would share similar kinds of implementations, but it's really the where you send it part that would change. I have no idea when I'll get around to looking at that, but it's something that's in the back of my mind that I'll probably talk to some other Lustre developers over the next couple days. This slide doesn't relate to any of that past stuff at all. This is just a bunch of other random things that we've worked on, and this was the best place I found to put it. So the max OBD devices thing, a lot of Kubernetes and like containerized environments want to mount Lustre a lot of times. There used to be a hard limit in Lustre about how many times you can mount based off of this kind of strange concept of an OBD device. We removed that, so you can just mount it as many times as you want. I've tested it up to like at least 10,000. I think I started running out of memory on my instance around 100,000. You probably will never mount Lustre that many times on a single node, but it is in theory possible. So I spoke about in the previous slide deduplication. The improved LU OBD device handling is kind of in that same vein, just basically making Lustre nicer on the inside. Not so much a feature, but very helpful for development efforts. Another thing is, not a lot of people know that there's a disk health check in Lustre, but it's behind a configure flag, right? I don't really know how many people actually enable it, but in a future version of Lustre, I think 217, actually it's in 216 at least, you can just turn it on at runtime whenever you want. It's only for OSTs right now. I have a patch that expands it to other storage targets, but just haven't taken the time to actually fix that up and get it landed. The biggest thing is it's just breaking some quotas on the MDT, so got to figure that out. Yeah, there was general debugging improvements. Just the biggest thing I have that I want to get landed in the near term is instead of using the Lustre custom debugging, I have a patch that converts it over to using tracepoint. So I basically take all the normal Lustre messages and throw them into the trace buffer. So you can use things like ftrace natively with Lustre. I'm thinking originally it was going to be just a complete replace. I'm thinking more that it's going to be a configure option or something like that. I have to get around to rebasing all of that work, but you know, something to look out for. And then James mentioned this in his talk, unifying all the kernel modules. There's way too many of them, so we're just going to jam a bunch of them together. Probably like have a server module, a client module, maybe a common module, and then all of the networking and OSD stuff separated out. Yeah, so the final big thing I have to talk about is upstreaming Lustre to Linux. So James talked about this quite a bit in his talk. I'll talk about it a little bit more, I guess. But last week we were actually both at LSF BPF, which is the conference to talk about things that are going to land in Linux in the next 24 to 48 months with all the VFS maintainers and other big Linux people. Yeah, so generally I think upstreaming only has upsides for Lustre. In terms of just having better compatibility with super new kernels, more involvement of upstream kernel maintainers in Lustre. When we have to port Lustre to new APIs, it would be really great to have people that develop those APIs involved in that conversion. There's generally a huge benefit I see for AWS customers and just people in general, being able to support pretty much any odd platform with Lustre, just because distros will just natively include Lustre along the way. Of course, they won't all do it at first, but as they update kernels over time. Yeah, most of the work that I've outlined in the previous sections, I envision is contributing to this wider goal of getting Lustre into a better state that we can merge it into the Linux kernel proper. Whether it's doing static analysis, LLVM, making the testing story a lot easier, making the GDS work on a native driver. Yeah. So LSF had a talk there, basically talking about a lot of the same kind of stuff. If you want to get the whole rundown, there's actually a wiki that I created that talks about the general plan that we have laid out. There was generally a warm reception. I think a lot of the VFS maintainers would be happy to have Lustre, but we have a lot of stuff that we have to do before upstreaming. So some of the major decisions were definitely not doing the server right now. That's a huge batch of code that is probably too much to do in the initial pull. So focusing on narrowly the client and the client-related tasks. The biggest one is folios. James mentioned that, talked about it quite a bit. There's some patch series already from Sean Takeoff from HPE was working on that. There's also, we have to actually split the client and server. There's not a huge amount of logical code separation between them. There's a few modules, Portal RPC, OBD class, FLD, and FID, I think, are the biggest offenders of modules that are have a lot of intermingled client and server code. And then something I didn't list here, but actually splitting out the compatibility code from the core file system code. That's something that James talked about a little bit, and something that I've been working on quite a bit. Yeah, so I have that project page, keeping it relatively up to date with a list of tickets that we want to get done, high-level overview of how the project is going to progress, approximate timelines. I'm hoping that we can have something on the list within a year and get some feedback from upstream maintainers. And I also have a link tree. So it's a link to just various talks that people have given about this project. I have to update it a little bit when there's some stuff posted online about LSF with our recent talk. But I'm pretty optimistic just generally about the upstreaming effort. It's been a long time, a long project. But I think we have a pretty plausible plan to actually get there. And that's it. I've run out of stuff to talk about.
Do we have any questions?
Well, if anyone thinks of any questions later on, I also have my email up there. And this is right at the beginning of LUG, so feel free to just tag me. I'll happily talk about Lustre all day.
Thank you, Tim, for all your work.